Hello and welcome to this video introducing conic sections and the most straightforward example of them, specifically circles. We're looking at an interactive web page here where we're looking at a picture of a cone and we have a cross section through it. A cross section is most easily understood as if you were to have a sandwich and you would cut through the middle of that sandwich. You would be able to see all the layers if you open it up on the inside and be able to kind of see that if you cut that sandwich, it would be a rectangle on the inside of that. Same thing as if you were to cut a tree down and look at the rings on the inside. If you cut a tree, the cross section is a circle once you've cut it through the middle. So we have a cone right here, and we can kind of do different things to this cone. If I rotate, and I can see the cross section on the right-hand side on this graph. So if I am just rotating around the y-axis, you can kind of see as it moves here, it is going to be kind of changing shape from an oval to a circle, and you can kind of see how that might change as you kind of see it follow along on the picture above. And you kind of see it stretching out and then becoming a circle if you cut this cone horizontally perfectly through it. And the circle is what you get from this sort of cross section. And you know, if I move this circle towards the top of the cone, it becomes smaller. If I move it to the bottom of the cone, it becomes larger. And then if I change the radius of the cone, the radius of the circle changes as well. Now, if I change it along a different axis than y, if I start to move it in a different sort of way, I can get different shapes to come up. And we can now see some of those different cross sections that happen in addition to just the circle horizontally through this cone. And if we are going to move it around a little bit, I can change it and it turn into an ellipse or an oval. And then if I keep going, I can make it into a parabola, something we know from math class. And then you make it into a hyperbola by kind of make it into that sort of double parabola that you kind of see on the graph. And that is a quick-ish intro to conic sections, and specifically the most straightforward part of those kind of sections, which are circles. So we are working on deriving the equation of a circle using the example I have graphed in desmos.com as you see it in front of you. We have a circle in red and its center is this blue point h comma k. We're just picking non-specific points right now. And we have one point on the circle, x comma y. I could have picked any other point in the circle. I could have picked the one up here or the one at the bottom or right across the circle. So we want to start labeling and drawing on this circle a little bit. So the first thing I would do would be to draw the radius of the circle. So that would be just connecting these 2 points right here. So let's just draw a little radius line right there, and we'll mark it with an R for radius. And if we want to kind of look at how the circle is labeled, well, H and K are right here. So we know, and we could kind of mark down that right here on the x-axis is H. And we know right here on the y-axis would be K, since that lines up with the point of the center of our circle. And then we could do the same thing with the x and y axis. Well, we know up here on the y axis would line up with the y. And we know right down here on the x axis would line up with the x. And we could even draw a little, we could do some dots here to kind of show that they are lining up exactly where we have them on our screen here. So we can add a little dots leading up to those points so we can all trace them to where we're lining them up with. And we can do the same thing with our center of our circle, put in some dots as well. So we have everything lined up how it's supposed to, and we have our radius drawn, and we have everything kind of set up for us to start deriving this equation. When I say deriving the equation, that is a mathematical and science term for using a general example with no specific numbers involved and coming up with a formula that will always work no matter the situation. And that's what we're trying to do here with our equation of a circle. So if we think about this length right here that I'm drawing in purple, that is how different the x and the h places are on the x-axis. So I could say that that length in purple right there is how different, or that sounds like subtraction, x and h are. And so that would give us that length of that purple line. Let's do the same thing with the difference between y and k. So now I could draw an orange line right here for that line between those two. So that would just be y minus k. And I can write that right next to it in the same color, have that lined up. Now I have all of the sides of what looks like a right triangle on my circle. So we could even draw that right triangle symbol. So I can put a little right angle right there. And so if we have a right triangle, we can think about, well, what formulas do we know that are represented or used with right triangles? And the formula that almost everybody remembers is the Pythagorean Theorem. I have the Pythagorean Theorem in how it normally works written out here in light blue. Pythagorean Theorem is a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse. And this is true no matter what. And we want to just apply that to what we just did. We have two legs of our right triangle in our circle. We have x minus h is one leg, and y minus k is one leg. So we can kind of use those same colors to write out our theorem using this now. So I could write that I have x minus h squared and keep the rest of the formula the same, plus my y minus k squared in orange, y minus k squared. And we know that is equal to our hypotenuse squared, which in this case, our hypotenuse is just the radius of that circle. So we can write in our hypotenuse squared, or in this case, our radius squared in red. And so I've just written out an equation using the Pythagorean theorem, and that is actually the equation of a circle. X minus h squared plus y minus k squared equals r squared. And when we're using this equation, you would have h comma k right here is the center of any circle, and the r, or the square root of that r number on the end, would end up being the radius of any circle that we be using. And we can do a quick example here before we end the video. We could have a circle with a center at 5, -5, and a radius of 4. And if I wanted to put that into an equation of a circle, I would just do x minus the x part of my center, which is the h in our formula, squared, plus the y minus the y part, or y minus -5 squared, equals to 4 squared, which is the radius of when its radius is 4. And you wouldn't want to leave it like that with two negatives and also just a 4 squared. So our final answer for the equation of this circle would end up being x minus 5 squared plus y plus 5 squared would equal to 16. And that is really all there is to the circle equation. And we can use it to graph circles. We can use it to determine what the equation of a circle would be if we looked at it. And as you can imagine, that we be using this in lots of different areas in science and math, and we'll use these equations more in future videos. Thank you for watching.